All right, everybody, we're going to be talking about division of polynomials again. So remember that this goes back to just numerical long division, right? So if we have 573 divided by 24, and we were going to divide this using long division, then remember what we would do is we'd probably think about, okay, well, how many times does 2 go into 5, right? That's a way we can kind of start to work this out, right? Because we might not know all the multiples of 24, but we can kind of start by thinking about the first couple terms here. So 2 goes into 5 twice, right? And 24 goes into 57 twice, so we can put a 2 here, right, to begin our quotient. And then we would multiply 2 by 24, right? So we multiply that times that, and we get 48, right? And then what would we do? We would subtract, right? And we often don't put a negative here, depending on how you learned and what your style is. A lot of times people don't put a negative there, but we do subtract, right? So 57 minus 48 is 9, right? And then we'd bring down the next term, or the next number in this case. And so then we'd have 93, and we think about how many times is 24 going to 93? Well, a way to estimate that or start to think about is how many times does 2 go into 9, right? And it would go in 4 times, right? And 24 times 4 would be 96, so it's not quite what we need. So we need to go down to 3, right? So then 3 times 24 would be 72. All right, and then what would we do? We'd subtract again, right? And so we would get 93 minus 72 is 21. Okay, and since we don't have any other numbers to bring down, we could, like we talked about, you can add more decimals and get a decimal equivalent of this value, or you can just say 23 remainder 21, right? Or you could say 23 and 21 over 24, right? Which we could reduce to be 23 and 7/8, right? So those are all equivalent values and different ways that we've seen division before, right? Long division. So with polynomials, it's a similar process. So if we look at number 32 here, the first thing we can do is set this up as a long division problem, right? So remember, when it's a monomial, sometimes we can just distribute the divisor to each term in the dividend. But when it's a binomial, it doesn't work out to where you can cancel or reduce as readily. And so what we're going to do is set up a long division problem. So I'm going to put the divisor. There's some words we talked about in the last video, right? So the divisor comes first on the left, and then we put the dividend underneath the long division symbol here, okay? All right, and then what we're going to do is we're going to start out by considering the first 2 terms, right? The first term in the divisor and the first term in the dividend, right? And I'm going to think about, okay, well, how many times does x go into x squared? Okay, so remember, you can do this mentally or on paper on the side. X squared divided by x equals x, right? And so I'm going to just put an x up there. And then what we're going to do is multiply x times x and x times x, or excuse me, x times 3, right? So x times x is x squared. X times 3 is 3x. All right, and what are we going to do next? Just like we did with numerical long division, we're going to do the same thing with polynomial long division, right? We're going to subtract. And so remember, what we do is, technically we have a negative outside here, right? And when we subtract a polynomial, remember, we change the signs of everything inside. So this x squared will turn negative, and so will the 3x. Okay, so I just changed their signs, right? They happen to both be positive, so I changed them both to a negative. I circle the change just because when I go back and check my notes, I want to know that that's not something that I forgot about, right? So I can verify, oh yeah, I did that, or oh, I didn't do that if I didn't circle them. Okay. All right. So what'll happen is these will cancel out, which if you get the right value up here, these should usually cancel out. Here, these end up canceling out as well, right? 3x minus 3x cancel out, so that doesn't always happen. So we end up with basically a 0x right here, right? And then we can bring down the 6, okay? So now I can ask myself, how many times does x, the first term here, go into 0x? And the answer is 0, right? If I divide 0x divided by x, I would just get 0, right? 0 divided by anything is 0. And so we have an invisible 0x here, right? Okay, or just 0, I should say, right? Because the x's would cancel out even. But either way, it's 0, right? So we don't need to put the 0 there. And then basically that means our remainder is 6, right? So our answer here for this, for our quotient, is going to be x remainder 6, right? Or we could write that as x plus 6 over x plus 3. So right, remember, like we talked about in the last video, we put the remainder on top, right? And then we put the divisor on the bottom in the denominator. All right, so let's think about how do we confirm our answer. So if we have a division problem, we divide the dividend divided by the divisor and we get the quotient, right? So a way we can check is we can multiply the divisor by the quotient. If we multiply those, we should end up with a dividend, right? So we can try this out. So now we're going to hold off on the remainder. So what we're going to do is we're going to multiply x by x plus 3, right? So we're going to do that first, and then we're going to add 6, add the remainder, okay? And we'll see if that comes out to what our dividend is. So if we distribute the x, we'll get x squared plus 3x, right? And then we just bring down the plus 6. We don't have any like terms, and so we have confirmation here that this is the same as this, right? So this is something that you don't necessarily have to do every time. This is a process in itself already. So the directions on one of the sets of questions says find the quotient and the remainder, and then check by using the fact that the dividend equals the quotient multiplied by the divisor plus the remainder, right? So you don't have to do that on every single problem. But I do want you to try it on 31, which is the first question in that set. Okay, so on number 31, I want you to check. And then all the other questions, you don't have to check unless you're not sure, right? Then you can confirm by checking. And then this is something that on a test, if you have some time and you're not sure about your answer, you can check, right? You can multiply the quotient by the divisor and then add the remainder, right? And that should give you the dividend, right? So quotient multiplied by divisor plus remainder gives you the dividend.